Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R software. So you can recall that in the last couple of lectures we have discussed various measures of central tendencies to understand that how the data is concentrated in different parts of the range. So now in this lecture also we will continue with the same topic, and we will consider here one more tool, which is mode. Very frequently you have heard the words like mean, median, mode, etc. So this is the same mode. Now the first question comes here: under what type of condition the mode is used? You see, many times in many data sets we want to know what is the value around which the maximum frequencies are occurring, and it is very useful. Why? If you try to say in practice, if you ever go to the shop of a clothing or a shoes, most of the times you will find the shoe or shirt or say any other clothing of your size. Very rarely it happens that unless and until somebody has a very strange size, they will not find it. How this is happening? How the shopkeeper takes this decision that if there are shirts of the size say 36, 37, 38, 39, 40, 41, 42, 43, 44, then the shopkeeper cannot keep say 500 shirts of each size. But the shopkeeper would intelligently try to keep the maximum number of shirts for those sizes which are used commonly, which are asked by most of the customers. For example, if somebody needs a shirt of size say 48, this is very rarely happens, that unless and until there are some extraordinary conditions, people will not use it. No, there won't be any customer to buy it. So that means the shopkeeper wants to know that what size of shirts should be ordered the most from the factory. And suppose if he knows by his experience that okay, size number like 38, 40, 42, etc., they are more common, then the shopkeeper would like to order more shirts of this size from the company. And if the sizes like 37 or say 44, 48, they are not so common, then the shopkeeper will ask only for a small number of shirts of those size. Similarly, if I take one more example, suppose in your college there is a canteen. The canteen would like to keep different types of drinks like a soft drink, hot drinks, and some fruit juice, etc. And the objective of the canteen owner is that the canteen owner would like to serve each and every student of the college, that whatever the student want, that should be available in the canteen. So now the students may have different types of choices, like as somebody wants juice, somebody wants say tea, coffee, somebody wants cold drinks, etc. So the problem with the canteen owner is that how should he know, or how should the canteen owner should know that how many bottles of cold drinks, how much quantity of tea and coffee should be prepared, etc., so that no students returns empty-handed, or all the students are served with the required drinks whatever they want. So for that, the canteen owner wants to know of which drink the demand is maximum, whether it is say cold drink, tea, coffee, or fruit juice, and according to which the canteen owner will try to keep those things inside the canteen. So now this is the question which we are going to answer today, that if you want to know what is the value of the variable corresponding to which the frequency is the maximum, then you will get an answer of all such questions. and this is called actually the mode. And you will see that in the R software, there is no command to compute the mode as such directly, but you will have to do some manipulations, some steps you have to define. But I would like to caution you, in R software there is a R command mode, M-O-D-E mode. But this mode gives you the information about the nature of the variable. In your childhood, I am sure that you must have studied a chapter, modes of transportation. There will be a train, there will be aircraft, there will be a car, etc. So these are also the modes of transportation. And this mode corresponds to these modes which are related to the transportations, for example. So please don't use the command mode in the R software to find out the mode. It will give you something else. But how to compute it, that is what we are going to discuss in the lecture. So let us begin our lecture and try to understand the concept of mode, to understand how it will give us an idea about the central tendency of the data. Okay, let us begin our lecture. So for example, I have given you now the example that where this concept of mode is going to be used. Fruit juice shop owner wants to know which of the fruit juices is more preferred, so that the shopkeeper can keep that fruit in the maximum quantity. And clothing shop owner wants to know that which side of the shirt or trouser is highest in demand. So essentially they want to know that which of the value has got the maximum frequency. So the mode of say n observation, suppose you have got here n observation x1, x2, xn. Now you will understand the meaning of this, right? So the mode of this n observation x1, x2, xn is the value which occurs the most compared with all other values, right? Suppose if I say suppose the fruit juice shop owner goes to suppose 100 students and ask which fruit juice do you want, say coconut or say mango or say orange. There are three possibilities suppose. And suppose 70 people out of 100 says coconut, 20 people says mango and 10% says orange. So what do you understand from this? That means the shop owner should keep the coconut more than the mangoes and orange. Right, so this coconut will be the mode. This will give you the information about the mode actually. So now, this mode is the value which occurs most frequently in a set of observations. And this mode is not at all affected by the extreme observation. For example, if you remember, in the case of arithmetic mean and median, I had shown you that how they are affected by the presence of extreme observations. Right. But in the case of mode, it is not affected by this extreme observations. The frequency distribution which have got only one mode, they are called unimodal, and those frequency distribution which have got two modes, they are called bimodal. And if there are more modes, then it is multimodal. For example, if the frequency distribution is unimodal, it will look like this. If bimodal, it may look like this, and if there are more than one modes like this one, it will look like this. Right. So you can see here, this is the height where the maximum frequency is occurring. So this will be here the mode. In the bimodal, there are two values where there are maximums are appearing. So they will be the two modes, mode 1 and say mode 2. And similarly, in the multimodal also there will be more than one values which can be called as modes 1, 2, 3, 4. Right. Now, the mode of the frequency distribution can be obtained, or I would say that there can be two types of data set, grouped and ungrouped, and the modes can be obtained in both the cases, but the approaches are different. So first we try to consider the mode for ungrouped data. So for discrete variables, the mode of a variable is the value of the variable having the highest frequency in a unimodal distributions, right? Usually we don't write the word unimodal because we assume that that there is only one mode, but we have to be on the safe side, right? So now the next question comes here, how are we going to create this mode in the R software? As I said, the mode is not available here, but before I try to do anything, let me try to show you here, because it creates a lot of confusion that when you try to find out the mean, then mean is given by mean, median is given by median. So people think that why not mode will give us the mode. So if I try to define here x equal to here 20, so now you can see here what is the mode of this here x. So this will give you here, this is numeric. And if I try to define here y is equal to say here true like this, then what is here the mode of y? You can see here this is here character. So this is actually what is obtained by the mode, right? Okay, so if you want to find out the mode, then we have to go in two steps. First, we have to create a table of given data vectors or the matrix so that I can obtain the frequencies of the data, right? Suppose my data is given by the name data, and this table is saved as a name of mode tab. So I'm just trying to give it here a name which you can easily understand, mode table. And for that we have to use the command table and as dot vector data, right? And because if you try to see, you want the first rows of the mode tab, which is this has to be a sorted list of all unique values in the data. I will show you as an example. If you remember, when you used to use the command here table, then it will try to give you here 1 to 70 and say here 90. So these were the categories and these were the absolute frequencies. So in the first step, we try to find out this first row of this mode tab or this data vector here, mode tab we try to create. Then in the step 2, we use the command here, like as here, we will try to find out the maximum value of the mode tab, which is there, data, and we will try to see that is it equal to the mode tab. This is the logical equality sign. And then I will try to find the names of the tab data where the mode tab data is the same as, is logically equal to the maximum value of the mode tab data. So what does this actually mean? I will try to show you with an example, then it will become very simple and very clear. Suppose I take here artificial data, suppose here 10, 10, 10, 10, 2, 2, 3, 4, 5, 6. So you can see here this 10 value is occurring 4 times, 2 is occurring 2 times, 3 is occurring 1 time, 4, 5 and 6 they are occurring 1 times. Now we try to create here a data. We try to use this data with the table command and we get here this mode tab, table as dot vector data, which is your here mode tab. So you can see here these are the value here, this 2, 3, 4, 5, 6, 10. What are these things? They are the values in the data which are occurring. For example, in this data set, if you try to see which are the values which are occurring, 2 is occurring, 3 is occurring, 4, 5, 6 are occurring, 4, 5, 6 and then value 10 is occurring, so 10. So this 2, 3, 4, 5, 6 and 10, they are given here. So these are the sorted list of all unique values in the data. And after that, the absolute frequency of these values are given. For example, 2 is occurring 2 times. These are the absolute frequency. 3 is occurring 1 time, 4 is occurring 1 time, 5 is occurring 1 time, 6 is occurring 1 time and 10 is occurring 4 times. So now if you try to see what is the definition of the mode, this is the value which is occurring for most of the time. So if you try to see the value which is occurring here for most of the time is here 4 and corresponding to which this value here is 10. So that means the 10 is the mode. So now in order to obtain this thing, we are trying to say, please find the name of the data vector mode tab where the mode tab is logically equal to the maximum value of the data in mode tab, right? So it is trying to find out that whichever is the maximum value in this data in 211114 and which is coming out to be here 4 and it is giving you the name of this 4 or the corresponding data which is occurring 4 times, which is here 10. So this is how you can very easily compute the mode of the data. So this is the screenshot of the same operation. And now let me try to show you that if the data is given in the form of here matrix, then how are you going to find out the mode? Yeah, in the data set can be stored in different formats. So for example, you can see here their data is here is in a 3 by 3 matrix, and which is given here like this. So where you can see here 1 is appearing here 1 time, 2 is appearing here 2 times, 3 is appearing here 2 times, 4 is appearing here 1 time, 5 is appearing here 1 time, and 6 is appearing here 2 times. So now you can see here there are more than 1 values which are occurring twice. You can see here these are here 2, 3 as well as here 6. So now under this type of situation what to do? So we try to follow the same steps. I will use here the mode tab, and then I will say here table as dot vector data, and then I will get here this thing. So you can see here this mode tab is given you the same thing, that number 1 is occurring 1 time, 2 is occurring 2 times, 3 is occurring 2 times, 4 is occurring 1 time, 5 is occurring 1 time, and 6 is occurring 2 times. And now from this I try to find out here what is the name of this mode tab, where mode tab is logically equal to the maximum values of mode tab. So you can see here that in this case there are 3 values 2, 2, 2 which are occurring maximum time, and corresponding to which the values are here 2, 3 and 6. So this is the outcome which is given here. So you can see that it's not a very difficult thing to obtain the mode, and this is here the screenshot of the same operation. But now let me try to first give you this example on the R software so that you can actually see what's happening. So let me try to save this here data, and you can see here this is your here data. Now I try to use here the command here. I try to create here the mode tab data. So you can see here this is here mode tab data, mode tab. You can see here it is here like this. Then I try to find out the mode by this command. So you can see here this is coming out to be here 10. And the same thing if I do it here with the matrix data also. So you can see here this is my here data. And then I try to use here this mode tab table as dot vector data, and you can see here this is here mode tab like this, and then I try to find out the here the mode by finding out the names of the variable for corresponding to which the frequency is the maximum. So you can see here this is the 236. So you can see here it is not a very difficult job to compute the mode, although I agree it is not available directly, and so yeah, it may be possible that after some time somebody may write a program for the mode also. So now we come to group data, and we try to learn how we can find out the mode of the group data. So for a continuous variable, the mode is the value of the variable which has got the highest frequency density corresponding to the ideal distribution, which would be obtained if the total frequency were increased indefinitely and if at the same time the width of the class interval were decreased indefinitely. What does this mean? If you try to see, you had learned the concept of density plots, under which I have shown you there is a concept of here bins. So what it is trying to tell you that here if you try to create the frequency curve, and in which the bin width is decreasing and it becomes very small, under that type of smooth curve, if you want to know which is the point corresponding to which the frequency is maximum, then it is called as the mode, right. So now in the case of group data, the mode is obtained by creating a frequency table. So we try to divide the data into different class intervals like as E1 to E2, E2 to E3, and up to here Ek minus 1 to Ek. So there are k class interval. Then we find out their midpoints M1, M2, Mk. For example, the first midpoint M1 is obtained here E1 plus E2 divided by 2 and so on, and then we try to find out their say absolute frequencies F1, F2, Fk. So that this summation I goes from 1 to k Fi is equal to n total number of observation. And the way we had obtained the median class when we found the median of this group data, similarly we try to find out here the modal class. So modal class is a class corresponding to the maximum frequency. So you simply have to see where is the maximum occurring and corresponding to which that class will be the modal class. And after that this is the expression by which you try to compute the mode. So here this EL is the lower limit of the modal class, and DL here is the class width of the modal class. Now F0 is the frequency of the modal class, and F minus 1 and F plus 1, these are the frequencies of the class just before the modal class and just after the modal class, right? And based on that you can find the modes. So let me try to take here a very simple example that we considered earlier and find out the mode. So in this data, actually regular customer is visiting a shop every day and spends some time. So the time spent inside the shops in minutes is recorded for the 31 days. And then we want to find out the mode of this number of minutes. So it is like this: on the first day the customer spends 30 minutes, on second day it spent 31 minutes, third day again it spent 30 minutes, fourth day it again spent 30 minutes. So you can see here up to now 30 is occurring 3 times and so on, right? So now what we try to see here, that I try to divide this data into say different class interval of width 5. So 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, and their midpoints are like 15 plus 20 divided by 2, which is 17.5. And similarly I try to find out the midpoints of other class intervals. Then we find out here the absolute frequency by counting that how many values are lying in this interval. So there are no values which are lying in the interval 15 to 20, then we have 12 values lying in the interval 20 to 25 and so on we have obtained here. So out of this you can see here where is the maximum frequency. The maximum frequency is lying here, F18. So F18, this becomes your here modal class, and then this is equivalent to, and your F0 it becomes equivalent to F3, and then F minus 1 becomes equivalent to the frequency F212, and F1 is equivalent to your here F4, which is equal to here 1, right? And the class width DL is equal to 5. So now in case if you try to substitute all these things over here, that EL equal to 25, DL equal to 5, F0 equal to 18, F minus 1 12, F1 equal to 1, and if you put them in this expression you will find here the value of the here mode, which comes out to be here 31.52, right? So this is how you can compute the mode, but definitely we are not going to compute this mode on the R software, right? And because there is a reason that when we are trying to find out this mode for a continuous variable, usually in data science the data size is quite actually large, and in that way there is not much difference between the values obtained for the modes from this ungrouped and grouped data. So whether you find out mode by whichever method, there will be very small difference which may not be very significant. So you can simply use them as ungrouped data and find out the mode, right? So that is why we are not going into these things. But anyway, I stop here, but my request to you is that please try to look for some situations where you would like to use the mode. Please try to look for some situation around you where this mode is going to be very useful, right? And if you try to see, the one very good example is that sometimes your mom thinks that what she should cook so that you become happy. And suppose you are upset and your mom wants to make you happy. What she does? She will try to cook your favorite food. Now the question, how she knows that which is your favorite food? Then she collects the observation that whenever she cooked dish 1, dish 2, dish 3, etc., how many times you became happier and you appreciated it. Then she will try to find out that, okay, which was the dish where you were happiest for maximum number of times, and that she will try to cook. So she will also depend on the value of mode. So similarly try to find out such more example to convince yourself that mode is really useful in real life and people need it. And in data science also, you need this in many situations where you would like to see that what type of customers are visiting the website more oftenly, what is the requirement of the customer on the website. For example, if you try to take a website where everything is available, electronics, clothing, footwear, etc., the website owner would like to know that what are the requirements, what people want, what customer wants. So for those things, this type of data analysis is very helpful, by which you can find out the mode and supply to the website owner, and he will also be happy. So I request you, please try to take some data and try to find the mode of that data, try to practice, try to get more conversant with this concept, and try to think that under now what type of data requirements you will use which type of tool, arithmetic mean, median, partition values, or mode. So you try to practice it, and I will see you in the next lecture. Till then, goodbye.